In this example, we have an equation which has in its base the variable x. So the equation says twice of log to the base 2x plus 1 of log of 2x plus 4 minus log of to the base 2x plus 1 of 4 equals to 2. Now how to go about this? So just look at what the terms we have. So the term essentially says that we have log base 2x plus 1 log of 2x plus 4 whole square minus log 2x plus 1 4 equals to 2, right? So there's a minus sign here. So in terms of log, that means we have a division out here because the bases are same, right? The bases are same. So essentially I have 2x plus 4 whole square upon 4 out here equals to 2. So this means now by the definition of log, what do we have? We have that 2x plus 1 whole square equals to 2x plus 4 whole square by 4. Okay? So that's what we have. So if you open it up, what will we get? We will get 4x square plus 1 plus 4x equals to 4x square plus 16 plus 16x whole upon 4, which equals to essentially x square plus 4 plus 4x. So from here we get that 4x and 4x get cancelled out, and what we will be left with will be 3x square minus 3 equals to 0, and that should imply that x square minus 1 equals to 0, and that implies that x square equals to 1, which implies x can take the value 1 and minus 1. Now 1 and minus 1 are the values that we have. So we need to now know what is the domain. What is the domain of this equation? What kind of x can we take? Now according to the equation, what do we have? According to the equation, whatever is inside the logarithm should be greater than 0. So therefore 2x plus 4 should be greater than 0, which implies that x should be greater than minus 2. Now in both the cases, x is greater than minus 2. X equals to 1 and minus 1. Both are greater than minus 2. But to get an answer, substitute back in the equation and check. My doubtful value is x equals to minus 1. So I would just want to check that. Now the base this time this is because the base this time is dependent on a variable, on this variable x. Now base is 2x plus 1. In case x equals to minus 1, then the base becomes minus 2 plus 1, which equals to minus 1, and the base cannot be negative, right? Base cannot be negative. So we have to ignore this value. Therefore, x cannot be equal to minus 1, and the solution that we have, solution is just x equals to 1. So this is another thing that you will always have to keep in your mind while looking into a solution.